Atoms, the basic unit of matter, seldom exist independently in the nature. Atoms have the tendency to combine to other atoms and form molecules. Molecules are the building blocks of substances. An atom combined with another atom chemically, and the numerous chemical combinations produces the numerous kind of molecules, hence the numerous kind of substances that we see all around us. The soil, the stone, the water, the wood, all are made up of molecules which are the product of combination of two or more atoms. But the question is, why do atoms aim to combine with another atom? We know that in an atom, there is always an equal number of negatively charged particles, electrons, and positively charged particles, protons. So, electrically, an atom is neutral. Still, atoms are restless, dissatisfied, because they are unstable. As any other thing in the universe, atoms too want to achieve stability. The stability for an atom means to have the electronic arrangement in their outermost shell, just like their nearest inner gas. The group 18th of the periodic table accommodates all the inner gases. The inner gas helium has only two electrons in its single shell. The atoms of other inert gases such as neon, argon, krypton, xenon, and radon all have 8 electrons in their outermost shell. The atoms which has 2 electrons in its valence shell is said to be in duplet state, and the atoms which have 8 electrons in their valence shell are said to be in octet state. Both this duplet and octet state give stability to an atom. For this reason, the atoms of these elements are inert, means inactive. They generally do not participate in chemical reaction and can exist in the nature as monoatomic. Except hydrogen, the atoms of all other elements want to achieve the octet state and get stable. And for this reason, they combine with one another and reshuffle the electronic arrangement of their outermost orbit. As in this process, the chemical spaces electron is involved. For this reason, this is a chemical process. An atom can combine with another atom in two ways, either by complete transfer of electron or by sharing of electron. When a metallic atom combine with a non-metallic atom, they go for a complete transfer of electron. The metallic atoms have low ionization potential and lower electronegativity. For this reason, they can readily discard their valence electron. On the other hand, the non-metallic atoms have high ionization potential and higher electron affinity. For this reason, non-metallic atoms can readily accept electron. So when a metallic atom discards its valence electron, the non-metallic atom can readily accept that. And as there is a transfer of charges taking place, the metallic atom becomes a cation and the non-metallic atom becomes an anion. And both the oppositely charged ions face the strong electrostatic force of attraction, which binds the two ions together, forming the molecule of a new compound. The bond which binds the two oppositely charged ions is called the ionic or electrovalent bond, and the compound they form is called the ionic or electrovalent compound. Let's take the example of NaCl for better understanding. Sodium, the metallic element, lies in the first group in the periodic table. With atomic number 11, sodium has valency 1. Sodium wants its outermost electronic arrangement, just like its nearest inert gas, argon. On the other hand, chlorine, the element of the halogen group, has atomic number 17. In its outermost shell, chlorine has 7 electrons. Chlorine wants to gain the electron arrangement of its outermost shell, like its nearest inert gas, argon. The electronic configuration of sodium is 2, 8, and 1. And the electronic configuration of chlorine is 2, 8, and 7. So both are monovalent atom. So when sodium discards its lone valence electron, then its penultimate cell will become its valence cell with 8 electrons in it. On the other hand, after accepting or receiving the donated electron, chlorine will have 8 electrons in its outermost shell. So both the atoms will get the octet state. But simultaneously, as there is the transfer of charge has taken place, both the atoms will get ionized. The sodium will become the sodium cation and the chlorine will become the chlorine anion. And both the oppositely charged ions will face the strong electrostatic force of attraction towards each other, and they will combine together, forming the molecule of the compound sodium chloride. On the other hand, when two nonmetallic atoms combine with one another, they simply overlap their valence shell and contribute equal number of electrons to make electron pair. The electron pairs are shared mutually by both the nuclei. The shared pair of electrons are attracted by both the nuclei by the molecular force of attraction, which binds the two atoms together and produce the molecule of a new compound. This type of bond, which is caused by mutual sharing of electrons, is called the covalent bond. And the compound that is formed by sharing of electron is called a covalent compound. Let's take an example of hydrogen for better understanding. Hydrogen, the first element in the periodic table, has a single electron in a single cell. Hydrogen wants the electronic arrangement of its nearest inert gas, helium. So, in order to gain or in order to attain the duplet state, a hydrogen atom would like to combine with another hydrogen atom. The two hydrogen atoms overlap their shell and contribute their single electron, making an electron pair. The electron pair is attracted by both the hydrogen nuclei, which binds the two atoms together, forming the hydrogen molecule. So the bond between two atoms in hydrogen molecule is the covalent bond. But whatever be the process to form a bond between two atoms, it may be the complete transfer of electron or the sharing of electrons. As the chemical species electron is involved in this process, this is a chemical bond. Chemical bond is the strong force of attraction which binds two ions or two atoms together as a single stable unit.